geometric word problems. In the next few lectures, we're going to be talking about applied word problems. The first word problem that we're going to deal with is a geometric word problem. Now, a geometric word problem is simply a story problem that involves some type of geometry, either a circle or a rectangle, a square, something geometric, something that we can draw. Let's look at the length of a rectangular lot is 6 meters less . Now we can easily see that this is a geometric problem since we're talking about a rectangle. Okay? Let's first put up some steps. There are 6 basic steps for solving any applied word problem. Now you may wish to write these steps down and have them on the side as we're working out this example, and I'll refer to these 6 steps and decide what must be found. We'll use a sketch if necessary. Now, in just about every geometric word problem, we'll always be able to do a sketch. Step 2, choose what it represents. Step 3, write an equation using the given information and the variable from step 2. Step 4, solve the equation. In step 6, check your answer. Now, let's go back to the problem, and we'll refer to these 6 steps. So here's our problem. Step 1 was to read the problem carefully and decide what must be found. Use a sketch if necessary. Well, let's read the problem. The length of a rectangle is 6 meters less than 3 times. So I read the problem. Now what must be found? Well, we must find the length and the width. So that's the first step. What do we want to find out of this problem? What is our goal? Well, our goal is to find this length. Sketch, I can even sketch a rectangle. I'll go to step 2. Now again, you may want to rewind and go back to those steps. I know that I need to find the length and the width. Step 2 says choose a variable. And this is the important word here. We want to choose the goal here is to find a variable that describes the width, and we'll find a variable that describes the length. Now each variable has to be the same though. Okay, remember, it says the length is 6 meters less than 3 times the width. I'll write that down. The length was equal to 6 less than 3 times the width. Equal the width. Now, how can we represent the length with this variable w? Well, right here it says that my length is 6 less than 3 times the width. So it's 6 less than 3 times the width. My length is also described. Okay. Step 3. ways to represent our length and our width. Equation. Step 4, solve the equation. So let's go back to the original problem. It says that the perimeter is 84 meters. Well, what does perimeter mean? Well, perimeter is just the distance around. Well, if I've got a W here, then this, if I have 3W minus 6 here, this is certainly 3W minus 6. So the equation to 3W's minus 6, and that must equal the total perimeter of 84. Now let's go ahead and solve. 2W, I'll distribute using the distributive property. Let's add these together. These are my like terms. Equals 84. I can add 12 to both sides. 8W is equal to 96. W is equal to, what's that, 12. So I have solved my equation. Well, that represents the width. So far, we've come up with W equals 12. Well, if our W is equal to 12, and our length is 3 times W minus 6, that means our length must be 3 times 12 minus 6, which is 36 minus 6, or 30. So we've answered the problem. The width equals Step 6 is to check our answer using the words of the original problem, not your equation. Why is this so special to use the words of the problem, not your equation? With the original problem. So let's that our length is 6 less than 3 times the width. So let's see if that's true. Let's see. 3 times the width is 36, minus 6 is 30. So that checks out. And is the perimeter of our rectangle 84? 30 plus 30 is 60, and that in fact is 84. So we did check our problem. Now there are several steps of this, but the more you practice, so make sure you have these steps somewhere in front of you as you attack these geometric problems, and you should have little to no problem after a while.